to start looking at linear programming now, which is Chapter C, or part of the chapter. So C, and we'll be looking at 2C1 and 2C2. So we've looked at stuff previously in regards to constructing constraints, graphing linear equalities, using inequalities, finding the constraints so we can find feasible regions or the simplex. So what we do in linear programming is we look at finding the optimal value. Okay, so that might be the maximum or the minimum depending on what we're looking at. What we want to go back to and have a bit of a think about is that opening problem we looked at with steaks and sausages, and we had $20 to spend at most, or we could spend less. Now, if we think about buying one sausage and one steak, it was a feasible solution for Jason and Kate, but do we think it's really a sensible solution? Now, we would say no, because one of each really isn't going to help them achieve their objective, which was to raise money through a fundraiser. So if they had one steak and one sausage, they're really not going to make any profit, or very little. So obviously we need to look a little bit more information about the best combination of steaks and sausages they could buy, and we find that through finding an optimal solution or an optimal value. So we've usually been given sets of constraints. There can be many possible solutions which satisfy these constraints, but now we find that optimal solution which meets the particular objective, which is usually looking at maximising profit or minimising costs. So what will happen, we'll have a bit of a look here, is what we call the simplex algorithm. Is that where we find the optimal value of the linear expression over a simplex occurs at a vertex of the simplex. So simplex, remember, is our feasible region. So if we look at this example here, what they've done is they've graphed these two, where is it? Here it is. 5x plus 4y is greater than or equal to 32, and 3x plus 4y is greater than or equal to 24. Now we know when the ax plus bx before c is greater than, we know our simplex or feasible region is on the outside, as you can see here. So what we will be doing here is we'll be trying to minimise that function. And now we minimise that function with this here, which is what we call, we'll have a look over what we call our objective function. This is what we do when we do some problem solving, but it's our objective function. You get given this in the first part of this chapter, so it's 2C1. You can see here the other constraints that we have are x are greater than or equal to 0, or y is greater than or equal to 0. And from there, you find the coordinates of the simplex. So this one would be 0, 8, 4, 3, and 8, 0. Now, what you do with those ones there is we then put them into our objective function. So if we were to make x 0, y 8, the total would be 8. If you sub these ones in, it'd be 4 plus 3, 7, and it'd be 8 plus 0, 8. Meaning that this coordinate here, or this point here, would be the point of optimal value for trying to minimise the function that we currently have. Here's another example. It's shown in a little bit more detail. So you've got 5x plus 4y is our objective function. You've got x is greater than or equal to 0, y is greater than or equal to 0, so this part here. 2x plus 3y is less than or equal to 18, and 4x plus 3y is equal than or less than or equal to 24. So that's been graphed here. So you can find that your simplex or feasible region, whichever is easiest to remember for you, is here. What we then do, find your coordinates, which we've already looked at previously. 0, 6 for the first one, 0, 0 will be down here, 6, 0, and 3, 4. Now, because this is below the line, because we've got less than or equal to, so it's below, we want to find the maximum value. So what we do is we create a little table here with our vertexes or our coordinates. We substitute them in to our objective function, the 5x plus 4y. So 0, 0 is always going to be 0, 0 and 6, so 5 times 0 plus 4 times 6, 24, and so on, as you can see, and we find our maximum point. So the 3, 4 will be our maximum point that we will just have for this one. So the way to finish this off, so the maximum value of 5x plus 4y over the simplex, which is this, is 31, is occurring when x is 3 and y is 4. Now, if we look at a question here, so this is question 1 of 2C1, what we need to do is sketch the simplex defined by x is greater than or equal to 0, y is greater than or equal to 0, 2x plus y is less than or equal to 8, and x plus 2y is less than or equal to 10. So obviously we need to be able to plot the points or be able to create the lines for these two. So the way I would be doing that is by finding the points on the y-intercept and the x-intercept. So for the first one, you would have, if you make x 0, we would have y is 8, and if we make y 0, it'll give us 2x is equal to 8, but then you have to obviously get rid of it. It would be x is 4. X is 4. So that's the first one over here. This one here would be if we make x 0, y would be 5. If we make y 0, x would be 10. So what I've already done, I've pre-prepared a graph for this one. So if we have a look at that, you can see that x is greater than or equal to 0, so that's that line there, so it must be above there, forward from there. Y is greater than or equal to 0, so it must be above there. Now we draw in the line, so if you've got y is equal to 8 and x is 4, that would be this red line here. So we must make sure that we label that line. Obviously meaning that this one here with our y-intercept of 5 and x 10, which is further down here, that becomes x plus 2y is greater than or equal to 10. So what we do from here is we need to then move this one up for us. Then we need to state the coordinates of the vertices of the simplex. So obviously, because we know that it's less than or equal to with the array x plus by, that means the simplex will be below our lines. So we need to find the coordinates. So the easy one to start with is down the bottom here. We've got 0 and 0. The one over there will go from here, we'll go across, it'll give us 4, 0. The next one up, so we'll go this one first actually, sorry. We'll do 0 on the x-axis, 5 on the y. And this one here, you come across as 2 and 4. Now, you can check this one here, you can check that by hand by either doing substitution method or the elimination method. You can read it off the graph like this, and I will also show you how to do that on the graphics calculator. So if we were to draw up this one on our calculator, you need to make sure that your functions are correct. So with this one, obviously y would be less than or equal to, so I need to change the type. Y is less than or equal to, we have 8 take 2x. Now with my calculator I have an issue with not being able to get the function for the fraction up, so if I make that a bracket for the first part there and then divide the whole lot by 1, but I'm not going to have to actually do that for that one, so that'll be fine just like this. So 8 takes 2x, next one down, which was our y. Now we need to change the type on that one again, just to make sure they're in the correct form. So y is less than or equal to, we have 10. This one we will have to do it, I'll put in the bracket, 10 take 2x, bracket, and then I'll divide by the 2 so we can make y by itself. Chuck that one in. Now, because x and y are both greater than or equal to 0, we must also have that in there so that it graphs correctly. Y is greater than or equal to 0. Next one down will be y, so we keep going across. So x is greater than or equal to 0. Let's put that one in. Then we'll draw that one. Draw that in. And there we go. We might zoom in for this one. New window. Make that one 15 for this one. That one. We'll go back, draw that one again, so it's hopefully a bit clearer. So there we go, that one's there. Now we want to find this intersecting point here. So what we do is go shift, G-solve, go to the intersection. Now it will show that line for here, so I'll click that. Shows the other line that I want to find the intersecting point, click that in. Gives me an answer of mistake with my function that I put in, which can happen. So what I've done here is I've got to come into here because for some reason I put that as 2x, make that x. Draw it in again. I should get this right this time. Go shift, G-solve, try again, intersect, shows the first point, shows the other one we want. Get that, and it shows up that x should be 2, y should be 4. So beautiful, we've covered that one. So these are our vertex for this here. This will be our objective function, which is the x plus y, which we find for C. This is for question part C. So you want the x plus y, so you put your objective function. So 0 plus 0 is 0, 4 plus 0 is 4, 0 plus 5 is 5, 2 plus 4 is 6. So this here would be our maximum optimal solution. So find the maximum value of x plus y over the simplex. That would be this one, which also would be this section here. So that's your 2, 4, your 4, 0, 0, 0, and your 0, 5. So the answer to that question, you'd be stating the values of x and y. X is 2, y is 4, and that would be your value there. Alright?